Hi all, here's another video, and this time we're looking at forces which create an acceleration on a body. So the question reads, calculate the effort required in the direction of motion to accelerate a 50 kilogram machine table from rest to 5 meters per second over a distance of 300 millimeters. The coefficient of friction between the table and the base is 0.25. So the first thing we want to do is draw our block diagram, our force diagram, and look at all the forces that are acting on the body, or in this case the machine table. So there's our diagram. Well, first off we have weight, and in the vertical we'll have our reaction force. Okay, as motion is in that direction and acceleration is that direction, we must have an out of balance force in that direction which equals ma. As motion's in that direction, we'll have friction in that direction and our effort must be in that direction. So now we've drawn all the forces, we can start analysing them. Well, the easiest one to work out first would be the weight. So the weight equals 50 kilograms times 9.81, which equals 490.5 newtons. That's the weight acting down. As it's in equilibrium, the weight acting up must equal the weight acting down. We have no other vertical forces acting anywhere, so therefore our Rn must also equal 490.5 newtons. So we've got the weight, we've got the Rn. The next thing we can calculate is the friction, because friction equals mu Rn, which will equal our 490.5 times 0.25, which equals 122.625 newtons. So now we have the friction. Well, our effort must overcome the friction and also give us an out of balance force which equals ma. So therefore we can write our equation, our effort equals friction plus ma. We have the friction, we have the mass, we need to calculate the acceleration. Now the question does give us enough information so we can use our kinematic formulas to calculate the acceleration. In this case, u equals 0, v equals 5 meters per second, and our distance equals 0.3 meters, 300 millimeters. So a is what we're looking for. Now we use the equation v squared equals u squared plus 2as. As u is 0, that just drops out the equation, and we rearrange the formula so we end up with v squared divided by 2s equals a. We can now solve our acceleration. 5 squared divided by 2 times 0.3, and that equals 41.667 meters per second. Now we have the A, we can calculate the out of balance force. So the out of balance force, ma equals 50 times 41.667, which equals 2083.33 newtons. Now we can go through and solve for the effort, because our effort will equal our friction of 122.625 newtons plus our out of balance force of 2083.33 newtons, and that combined equals 2,206 newtons required to achieve this acceleration.